Okay, welcome to the next solution video. We're going to solve from question 26 to 30. Question 26 says we should expand 2 over 3 minus x to the power of 6 and determine the coefficient of x cubed and x power of 4. We have n combination r times the first term to the power of n minus r times the second term to the power of r. This second term is minus x. So we have minus x to the power of r should equal to x to the power of 3. That means r should equal to 3 and r should equal to 4 for the two cases. So for the first case, when r is equal to 3, we have 6 combination 3 times 2 over 3 to the power of 6 minus 3 times minus x to the power of 3. We have 6 combination 3 equal to 6 factorial divided by 3 factorial, 3 factorial, which is 6 times 5 times 4 divided by 6, which is simply just 20. So we have 20 times 8 over 27 times minus x cubed. 20 times 8 is 160 divided by 27 times x cubed. So this is minus 160 divided by 27 times x cubed, which corresponds to option A. But that is just x cubed. There's no other option there for x cubed, but let's just find out what x power 4 is. For x power 4, we will find when r is equal to 4. And when r is equal to 4, we have 6 combination 4 times 2 over 3 times 2 over 3 to the power of 6 minus 4, that is 2, times minus x to the power of 4. 6 combination 4 is 6 factorial divided by 4 factorial, 2 factorial, which is 6 times 5 divided by 2, which is 15. So we have 15 times 4 over 9 times x power 4. 15, this is divided by a dash 3 divided by a dash 5. So that's 20 divided by 3 x power 4, which still affirms that a is correct because that is the second number that is there. Minus 160 divided by 27 and 20 divided by 3. So the answer for 26 is A. Question 27. Which of the following is the polar form of z is equal to 1 plus I? 1 plus I. First of all, you have to find the argument of this. The argument is that the argument star is equal to a divided by b. So the tan argument of theta is equal to a divided by b, which is equal to 1 divided by 1, which is equal to 1. The tan inverse of 1 is equal to 45 degrees. In this case, they are using pi, so 45 degrees is just 45 over 180 pi. 45 here 1, 45 here 4. So we have pi over 4. So the argument theta is equal to pi over 4. The second thing we need to find is the radius. Like, first of all, this is our polar form. First of all, we have found the theta that we have to rotate. So you have to rotate pi over 4 distance, and we need to just find the radius to determine which particular point. So that radius is equal to the square root of a squared plus b squared, which is equal to the square root of 1 plus 1, which is equal to square root of 2. So our polar form is equal to r times cos theta plus I sine theta. So our radius here is square root of 2. So we have square root of 2 times cos theta, that is cos pi over 4, plus I sine pi over 4, which corresponds to option C. Root 2 times cos pi over 4 plus I times sine pi over 4. So we have option C. 27, option C. Let's go to question 28. Question 28 asks us to evaluate cos pi over 6 plus I sine pi over 6 to the power of 3. Now, I don't really know what method you've been taught, but first of all, let me just expand this first. So we have cos pi over 6. Cos pi over 6 is going to be cos pi over 6. Pi over 6, that is 180 divided by 6. That's 30. Okay, that's 30. So cos 30 is going to be root 3 over 2 plus I 1 over 2 plus half I to the power of 3. So this is what they asked us to find. Now, for those people that don't really know imaginary numbers, complex numbers like this, like that, you can simply just expand this the normal way you know how to expand. Yeah, you can simply just expand this times itself, you write it down, this times this, you write it down, this times this, you write it down, this times this, you write it down. You can do that method, like you don't really know how to expand all this. But when I want to change this to Euler's form. Euler's form is basically just that one that has r times e to the power of I theta. So our theta here is going to be pi over 6. And our radius here is just 1. Our radius here is 1. So we have e to the power of I pi over 6. All to the power of 3. So e to the power of I pi over 6 is the same thing as cos pi over 6 plus I sine pi over 6. So this to the power of 3 is simply just e to the power of I pi over 6 times 3. 3 here 2, 3 here 1. So this is equal to e to the power of I pi over 2. We know from that Euler's formula that e to the power of I pi plus 1 is equal to 0. So e to the power of I pi is equal to minus 1. And if we square root both sides, we have e to the power of I pi over 2 is going to equal to the square root of minus 1. So e to the power of I pi over 2 is simply just I. Square root of minus 1 is I. So it's simply just I. And that's option C. So for question 28, we have option C. Cos pi over 6 plus I sine pi over 6 all power of 3 is simply just I. Let's go to question 29 now. Okay, question 29 is on the other paper. Question 29. Which complex number lies farthest from the origin? So now we have a Cartesian plane, or no, it's not Cartesian plane they call it. I've forgotten the name of the person that they call it for complex numbers. But we have his graph, his plane. I've forgotten the name they called it. I've forgotten the name. But we have this, that is a Cartesian, let's just call it the Cartesian plane, but it's not Cartesian plane they call it for complex numbers. If you know the name, please, you can tell me, but it's not Cartesian plane they call it for complex numbers. Okay, but we have to find the point that lies the farthest. Now, if you have a point here as radius equal to 1, and we have another point here as radius equal to 1, they are still lying at the same distance from the origin. So, but basically in this case now, none of them lie in the same place. But to find the one that lies outside the largest radius, and that radius, you know that radius is equal to square root of a squared plus b squared. So all you have to do is carry each option and test them to determine what their radius is. For option A, we have 2 plus I. So in this formula, we have square root of 2 squared plus 1 squared, which is equal to square root of 4 plus 1, which is equal to square root of 5. There's no need to evaluate square root of 5, just use the square root of 5. So we have the next option now is option B, which is the square root of minus 3 squared plus 2 squared. Minus 3 all squared, that is simple as 9, plus 4, that is square root of 13. The next one is minus 2 minus 2i. So that is equal to the square root of minus 2 squared plus 2 squared. 2 squared is 4 and 2 squared is 4. So that's square root of 8. Option C is square root of 8. And the answer here cannot be none of the above because there must be one that is farthest from them. Option D is 1 plus 4i. Okay, so that's square root of 1 plus 4 squared, which is equal to square root of 1 plus 16, which is equal to square root of 17. So we have option D is square root of 17. If you look at the four numbers here, the one that is largest is D, is equal to square root of 17. So D would lie at the farthest, no matter where it is. No need for you to check which angle it is. Just look for the radius that is the largest and use this formula to get the radius. So the answer is option D. 29, option D. So this it lies at the farthest distance from the origin. So option D, 1 plus 4i is the answer. The next one, the final question for this video is question 30, which says we should simplify 5 plus 2i. That is, we should simplify 5 plus 2i divided by 1 minus 3i. Multiply by the conjugate. So we multiply here by 1 plus 3i divided by 1 plus 3i. So if we multiply the methods, we have 1 minus x plus 3 squared. Because 1 times 1 is 1, 1 times plus 3i is plus 3i, minus 3i plus times 1, that is minus 3i. So that plus 3i and minus 3i, we get cancelled out. And the final one, we have minus 3i times 3i, that is minus 9i squared. And I squared is the same thing as plus 1. So that will just be this thing, 1 plus 10. 1 plus 9, sorry, that is 1 plus 9, which is equal to 10. So for the numerator, we have 5 times 1, that is 5, plus 5 times 3i, that is 15i. 2i times 1, that is plus 2i. 2i times 3i, that is 6i squared, which is the same thing as minus 6. So this is equal to 5 minus 6, that is minus 1. 15i plus 2i, that is plus 17i. So we have minus 1 over 10 plus 17i, which is option D. Question 30 is option D. So this is the final question for this video, the final video for this series. Okay, welcome to the final video for this series. We have question 31.